Royaling Space.
All right, young space explorers, get ready to blast off on an epic adventure. Have you ever wondered what lurks in the deepest, darkest corners of our universe? Today, we are traveling into one of the most mysterious and exciting parts of the universe. Black holes are invisible, powerful, and full of secrets. Even though we cannot see them, scientists have discovered many black holes close to our Milky Way galaxy by watching how they affect stars and light around them. In this journey, we will explore real black holes with true stories, learn where they live, and discover why they are some of the most fascinating objects in space. Get ready to dive into the darkness and uncover the wonders hidden beyond the stars. These cosmic monsters are not just science fiction. They are real, and they are hiding all around us. So buckle up, because we're about to explore the most fascinating black holes ever discovered. Let's start right at home, in the heart of our own Milky Way galaxy. Here, we find a supermassive black hole named Sagittarius A. This giant is 4 million times more massive than our sun. But don't worry, it's mostly a gentle giant. It sits calmly at the galactic center, acting like an invisible anchor, and its immense gravity holds our entire galaxy together. The stars closest to it orbit at incredible speeds, a silent cosmic dance choreographed by this unseen force. Without Sag A asterisk, our galaxy might not even exist as we know it. Now, let's travel to one of the pioneers of black hole discovery, Cygnus X1. This was one of the very first celestial objects that scientists confidently identified as a black hole. It's part of a binary system, hiding next to a massive blue supergiant star. Cygnus X1 isn't shy. It actively pulls gas and material from its stellar companion. As this stolen material spirals towards the event horizon, it forms an accretion disk. This disk gets superheated, glowing brilliantly in X-rays before it finally vanishes forever into the black hole's depths. It's a dramatic, beautiful, and terrifying process. Not far away in the same constellation is another fascinating object, Cygnus X3. This black hole also lives in a double star system, but it's known for being much more energetic. Cygnus X3 creates incredibly powerful bursts of high-energy particles and radiation that travel across space. These jets are like cosmic lighthouses, beaming signals that scientists can study to understand the intricate and often violent interactions between a black hole and its partner star. It's a natural laboratory for extreme physics. Speaking of violent outbursts, let's talk about V404 Cygni. This black hole is the drama queen of the cosmos. For long periods, it's completely dormant, just quietly sleeping in space. But when it wakes up, it does so with a bang. V404 Cygni is famous for its sudden, incredibly bright explosions. During these outbursts, it can become one of the brightest objects in the X-ray sky, briefly outshining entire galaxies. These dramatic flare-ups give astronomers a rare chance to study the feasting habits of a black hole in real time. It's a reminder that even the quietest corners of space can erupt without warning. Now, let's get a little closer to home with AO6 2000. This is one of the nearest known black holes to Earth, only about 3,000 light-years away. It appears quiet and unassuming, part of a binary system with a small, sun-like star. But don't let its calm appearance fool you. Its gravity is so strong that it's constantly siphoning material from its companion, creating a faint but steady glow. Its proximity makes it a perfect target for study, helping us understand the typical lives of stellar mass black holes scattered throughout our galaxy. If you want to see a black hole with some serious firepower, look no further than GRO J1655240. This black hole is renowned for its incredible jets. When it feeds on its companion star, it doesn't just swallow the material, it blasts a portion of it back out into space. And these jets are fast-moving at speeds approaching 90% of the speed of light. Watching these relativistic jets shoot across the cosmos is a stunning demonstration of the extreme power and energy that black holes can unleash. They literally reshape their environments. Next, we have GX 339-4, the chameleon of black holes. Its defining characteristic is its variability. It frequently and dramatically changes its brightness. One moment, it's a brilliant X-ray source. The next, it has faded into nerubs. This flickering behavior is tied directly to how it consumes matter from its companion star. By carefully monitoring these changes, scientists can learn how black holes switch their energy output on and off, almost like flipping a cosmic switch. Let's venture to a more unusual location for our next black hole. XTJ 1118 plus 480. What makes this one special is its position. Most black holes in our galaxy are found within the flat, crowded disk of the Milky Way, but this one is located high above that disk in what's called the galactic halo. Its lonely position raises interesting questions about how it got there. Was it kicked out of a star cluster? Did it form differently? Studying it helps astronomers understand the dynamic history and movement of black holes within our galaxy. Now, let's leave the Milky Way for a moment and travel to our galactic neighbor, the Large Magellanic Cloud. Here we find LMCX1. This powerful black hole is feasting on a giant star, and its accretion disk shines brightly in X-rays, making it one of the most luminous X-ray sources in that galaxy. It's a clear beacon that reveals the hidden presence of a massive object, helping astronomers hunt for black holes in other galaxies. Also, in the Large Magellanic Cloud is LMCX3. It's another black hole in a binary system, but it's much calmer than its neighbor, LMCX1. This provides a perfect opportunity for comparison. By studying two different black holes in the same galactic environment, scientists can figure out what factors like the size of the companion star or the rate of feeding influence a black hole's behavior. It's like having a control group for their cosmic experiments. Our intergalactic tour continues to the Triangulum Galaxy, about 3 million light-years away. There, we find M33X7. This black hole is a true heavyweight. It's one of the most massive stellar black holes ever discovered, weighing in at nearly 16 times the mass of our Sun. It's locked in a tight, elegant orbit with an even more massive star, creating a perfect cosmic dance. Studying this system challenges our understanding of how such massive black holes can form and exist in such close proximity to their giant partners. Back in our own galaxy, we have Maxi J1820 plus 070, a black hole that took the astronomical community by surprise. In 2018, it suddenly flared to life, becoming incredibly bright. What was amazing was that telescopes all around the world and in space were able to turn and watch it happen. This coordinated global effort allowed scientists to observe its outbursts across the entire electromagnetic spectrum, from radio waves to gamma rays, providing an unprecedented, detailed look at a black hole's feeding frenzy as it unfolded. Then there's GROJ 42 plus 32, a black hole that helped settle a long-standing debate. During a powerful outburst in the 1990s, astronomers were able to measure its mass very accurately. The measurement proved it was too heavy to be a neutron star, the other possible dense remnant of a dead star. This was a crucial piece of evidence that confirmed its identity as a true black hole, solidifying our methods for distinguishing between these two exotic objects. Some black holes are harder to study than others. Take Swift J1357.2-0933. This one is particularly mysterious because it seems to be hiding behind thick, dark clouds of gas and dust. We can't see it directly, but we can see its light flicker in a strange, dipping pattern. It's like we're watching a blinking signal from deep space. Scientists think this might be caused by a warped or lumpy accretion disk passing in front of the central source, giving us clues about the complex structures that form around feeding black holes. Remember V404 Cygni, the drama queen? It also goes by another name, GS 2023 plus 338. Its wild and chaotic behavior has taught us an important lesson. Black holes are not always the calm, steady objects we might imagine. Its unpredictable outbursts, with light echoes and powerful winds, show that the process of matter falling into a black hole can be incredibly messy and complex. It's a constant reminder of the dynamic and violent nature of the universe. For a more regular rhythm, we can look to IGR J1709-123-624. This black hole exhibits strange, repeating patterns in its X-ray emissions. Scientists have nicknamed its rhythmic pulsations a heartbeat. These cycles are thought to be linked to instabilities in the accretion disk, where matter builds up and then is suddenly dumped into the black hole. By studying this cosmic heartbeat, we can learn more about the physics of how black holes consume their meals. Next up is for you, 1543 to 47, which lives in a binary system and gave astronomers a gift in 2002 with a huge, bright outburst. This explosion made it incredibly easy to study from Earth. The observations allowed scientists to measure not only its mass, but also its spin. This showed how quickly black holes can grow and evolve, especially when they have a nearby star to feed on. Our tour wouldn't be complete without XTEJ 1550-2564. During a massive outburst, this black hole created spectacular jets of energy. But what was truly groundbreaking was that astronomers were able to watch these jets slam into the surrounding interstellar gas, creating glowing clouds of superheated material. This was direct proof that the energy from black holes can have a profound and lasting impact on their galactic environments, shaping the space around them. Finally, let's look at Swift. J1753.50127. This black hole is notable for its persistence. Unlike many others that have brief outbursts, this one has remained active for a very long time, over a decade. Its relative closeness and steady activity make it an ideal laboratory for studying how black holes can sustain their energy output for millions of years. It's a marathon runner in a world of sprinters. From the quiet giant at our galaxy's core to the dramatic explosions and powerful jets scattered across the cosmos, each black hole tells a unique story. They are not just cosmic vacuum cleaners. They are active, dynamic engines that shape galaxies, create elements, and push the laws of physics to their absolute limits. The more we study them, the more we realize how much we still have to learn about our incredible universe. Thank you so much for joining me on this journey through the cosmos. If you enjoyed this deep dive into the world of black holes, don't forget to like, subscribe, and hit that notification bell so you won't miss our next adventure. See you next time.
Royal Lane Space.